Okay, I want to walk through some of your homework problems. So you were asked to do investigation 18, parts E, F, G, and H. Um, and I'm not sure how much detail I'm going to show on each of these problems, but I just want to give you maybe um, a couple of ideas about ways that you could go about tackling these things. So looking at part E, and by the way, we did parts A through D together in class on Tuesday. So, but picking up now with part E, um, okay. So one way that that I think about doing this is I can think about doing it like just counting up like the columns, like the tiles in each column. So I know that this is 2 plus 2, right? So figure 1 I could call 2 plus 2, and then figure 2 I could call 3 plus 3 plus 2, and then figure 3 I could call 4 plus 4 plus 2 plus 2. And I can start to sense that that's not going to be very helpful in terms of establishing a pattern. Well, in terms of being able to come up with a closed formula for what the nth figure is, because like what would figure 10, for example, what would figure 10 be? It's like, how many of these stacks would I have? That's a little bit more challenging to kind of figure out. But if I can express it in terms of multiplication, then I think it's a little bit easier to see the pattern. So what I'm going to do is go back and I'm going to call this, 2 plus 2 like I did before. This one I'll call 3 plus 3 plus 2. This one I'm going to call 4 plus 4 plus 2 plus 2. This one I'm going to call 5 plus 5 plus 2 plus 2 plus 2. It's interesting on this one they give you figure 4, right? Okay, so now what I'm going to do is go back and let's see if we can express these in terms of multiplication. It's not exactly clear looking at the first figure what the pattern is. I think I might work backwards actually and start over here and say, well, I'm going to call this 2 times 5 and 3 times 2. And then this one I'm going to call 2 times 4 and then 2 times 2. And this one I'm going to call 2 times 3 and then 1 times 2. And if I do that, I do notice a pattern now, right? It's like, so the first number is always a 2. The second number is, well, it's not the figure number, but it's 1 more than the figure number each time, okay? The third number here is increasing 1, 2, 3. So it looks like it's the figure number minus 1, right? Figure number minus 1. And then this number here is always 2, right? So if I extrapolate that down to the next figure, it would be, so the first number is always a 2, so this is going to be 2 times. The second number is going 5, 4, 3, so I think it should be a 2. And so far that matches up, right? 2 times 2 is the same thing as 2 plus 2. And then the next set of numbers goes, it goes 3, 2, 1, and then 0, right? And then the next set of numbers is 2, 2, 2, so this should be a 2. So that matches up with the way that this number pattern worked, right? So I think this is working out pretty well for me. So if I think about what figure 10 would be in this sort of lineup, thinking about it in terms of the multiplication, it's going to be 2 times something plus something times 2. Right? Because the 2's, this 2 and this 2, are remaining the same in each of the figure numbers, right? It's always those. So that's what I've written down here. The question is what should go in here. So if you look at this second number, it goes 2, 3, 4, 5. So it's increasing by 1 with each figure number. It's related back to the figure number by being, it's the figure number plus 1, right? Figure number plus 1, figure number plus 1. So in this case, figure number plus 1 would be 11. And then the second number, or this number here we said was figure number minus 1, figure number minus 1, figure number minus 1, figure number. So here it's going to be 9. Okay, that's helpful. If I kind of extrapolate that now to figure 100, it's going to be 2 times figure number plus 1 plus figure number minus 1 times 2. And then once I've made that leap, going to figure n isn't that difficult. It's 2 times figure number plus 1 plus figure number minus 1 times 2. Okay. Anyway, we can simplify this. You should get 2n plus 2 here, and then here you should get 2n minus 2. Oh, that's very interesting, right? So that's just 4n. So you should just get 4n. So 4 times the figure number. That checks out, right? Figure 1, 4 times 1 is 4. Figure 2, 4 times 2 is 8. We have 1, 2, 3, 4, 5, 6, 7, 8. You know, that kind of gives me another way to think about this. It seems like what you could do, maybe, is just move some squares around. Like you could just stack these 2 squares on top of these 2 squares. And then you just have, 4 times 2, right? And here you could stack all 4 of these up here. And then you have 2 times 1, 2, 3, 4, 5, 6, right? 2 times 6. So 2 times 2, 2 times 4, 2 times 6, 2 times 8, probably, right? Anyway, so that's another way that you could maybe go about doing it. Here's another way. You could do it by sort of filling in the missing square like we've done in the past, right? So imagine just sort of completing this square and keeping in mind that that one's actually missing, and doing the same thing here and the same thing here. What I notice, so what I notice is that the thing that's missing is always a square. It's a 3 by 3 in the case of figure 4. It's a 2 by 2 in the case of figure 3. It's a 1 by 1 in the case of figure 2. And so we can kind of see that it's a 0 by 0 in the case of figure 1. Okay, and that's what you're missing. In the meantime, filling in the square is kind of nice because now you have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you just have a 5 by 5. And here you have a 1, 2, 3, 4, 1, 2, 3, 4. So you have a 4 by 4. So it's a 5 by 5, a 4 by 4, a 3 by 3, and sure enough, a 2 by 2. So, so I think what we could say is that this one here is a 2 by 2 minus a 0 by 0. And this one is a 3 by 3 minus a 1 by 1. And this one is a 4 by 4 minus a 2 by 2. Okay, and a 5 by 5 minus a 3 by 3. So it seems like what we have going on, if I kind of extrapolate to figure 10, seems like what we have going on is it's the figure number plus 1, right? Figure number plus 1, figure number plus 1, figure number plus 1. So for figure 10, that would be 11 by 11. Whoops, 11 by 11 minus figure number minus 1, figure number minus 1, figure number minus 1, figure number minus 1. So in the case of figure 10, it would be 9 by 9. And so kind of cutting to the chase, let's extrapolate this to figure n. It would be a figure number plus 1 by a figure number plus 1 minus a figure number minus 1 by a figure number minus 1. And then we can work that out, right? So we have to FOIL both of these. We get n squared plus n plus n plus 1. And for the red part, we get n squared minus n plus 1. Well, I'm going to simplify that. So we have a n squared plus 2n plus 1 minus an n squared, and now here let's be careful, negative n minus negative n, or negative n minus n is negative 2n, but when we distribute this negative sign it's going to become a positive 2n, and then when we distribute the negative sign to the positive one here, it'll become a negative 1. Well, we can combine our like terms now. The n squareds are gone, the 1's are gone, and we have 2n plus 2n, sure enough, is 4n. So there's another way that you could have done the same thing. So that's part E. I think I asked you, the homework asked you to do the 4 folds, right? So it asked you to do, a graph, a table, write down the equation. In this case, the equation is going to be y equals 4x. And if you graphed it, then you noticed that it was a straight line, and that your slope was constant, right? The amount of squares that you were adding from one figure to the next was the same each time, right? So this is linear growth. Okay, so part E is definitely linear growth. Okay. Anyway, I'm going to try to move through the others a little bit more quickly. So maybe I'll just give you like one way to think about these. There are multiple, okay? There are multiple ways to think about these, but I'm just going to give you one in the interest of time. So looking at part F, here's what I noticed. Like, I noticed that I have this weird square in each of the figures, but I also noticed that I'm missing a square in each of the figures. If I just move this square there in each of the figures, then it might be a little bit easier to figure out what's going on, right? So that's how I'm going to kind of think about this. I'm going to imagine it this way instead, with this square kind of filling in the hole. If I do that, then what I really have in figure 1 is a 3 by 4. Right? So figure 1 would be a 3 by 4. And then I have this extra 1 up here, right? So I have this extra 1 up here. So I'm going to say plus 1. For figure 2, I would have a 4 by 5. And then I have these extra 2, so plus 2. And for figure 3, I would have a 5 by 1, 2, 3, 4, 5, 6. So it would be a 5 by 6. And then I have these extra 3, so it would be plus 3. And I can extrapolate that out a little further. Right? So I can say, all right, I think I see where this is going. I think figure 4 is going to be, well, it's 3 by 4, and then 4 by 5, and then 5 by 6, and so then this should be a 6 by 7. And then I have an extra little bit, 1, 2, 3, 4. Okay, that's the pattern. Now the question is, how do these numbers relate back to the figure numbers? Because in order for me to extrapolate out to figure 10, I'm going to have to somehow relate these numbers back to the figure number. So what I notice is that these numbers are increasing by 1 each time. So I'm pretty sure that it's not like the figure number times 3, because 1 times 3 would be 3, but 2 times 3 would be 6, not 4. So I'm pretty sure what it actually is figure number plus 2. 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2, what did I say? 1 plus 2 is 3. 2 plus 2 is 4. 3 plus 2 is 5. So 10 plus 2 is 12. Okay? And then I'm multiplying that by, well, it looks like this is figure number plus 3, right? 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. 10 plus 3 is 13. So it looks like 10 by 13. And then I'm going to be adding on a little bit extra, right? Here I'm adding 1. That looks like the figure number. Here I'm adding 2. Well, that's just the figure number. Here I'm adding 3. That's the figure number. So for figure 10, I would be adding 10. Okay, figure 100. We decided that the first number was figure number plus 2. So 100 plus 2 is 102. We decided the second number was figure number plus 3. So 100 plus 3 is 103. And then we decided that the last number, the one that we're adding on, is just the figure number itself. So for figure 100, that would be 100. And so for figure n, it's going to be figure number plus 2 times figure number plus 3 plus figure number. Pretty sure this one is a quadratic growth, right? Let's FOIL this out. We're going to get n squared, 3n, 2n, and 6. And then this other n comes along for the ride. When we combine our like terms, we get n squared, 5n plus n is 6n. So n squared plus 6n plus 6. So that's what you should have gotten there. It's definitely a quadratic growth, right? If you were to graph it, you would see that you don't get a straight line, you get a parabola. The amount of increase from one figure to the next is not constant, okay? And the equation for the graph is x squared plus 6x plus 6, right? So this is quadratic growth. This quadratic growth. Okay. One thing that I want to kind of suggest to you is that when you have linear growth, the figures are usually only growing in one direction. Okay. Whereas when you have quadratic growth like this, the figures are growing in 2 dimensions. Notice that like these figures are not just getting taller, they're also getting wider. Okay, so they're growing in 2 dimensions. So that's sort of like the visualization, I think, for quadratic growth, right? They're growing in two different dimensions. Okay. Next one. I don't know why this reminds me of Star Wars or something, especially this one. Looks like one of those weird ships from Star Wars for some reason. Anyway, how can we do this? Man. I mean, if I kind of stick to my strategy in part F, one thing that I might think about is like, how can I move around the tiles to make each of these look like as close to a rectangle as possible? So like for the first figure, for example, I could take these 2 and move them and fill them in right here, and then I just have a 3 by 3, which is nice. If I try that on figure 2, it doesn't quite work out. If I move these 2 and put them in there, well, I get kind of like a weird sort of Tetris type of shape. So that doesn't work out, but if I move this square down here, right? So if I move this one here, and then I move these 2 here, well then that works out nicely. I have a 4 by 4. And let's see if I can do that for figure 3. I think if I move these 2 down here, and then move these 2 up there, well now I get a 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. So I get a 5 by 5. So this one, when I move these up here, I have a 3 by 3, and then a 4 by 4, and then a 5 by 5. Pretty sure the next one's going to be a 6 by 6, right? And I can kind of continue extrapolating from there. So I'm not going to complete that one, but I will say I'm pretty sure this is a quadratic growth, right? I'm pretty sure, since we're starting at 3 by 3, and then 4 by 4, and then 5 by 5, it feels like it's figure number plus 2. So I think in general it's going to be n plus 2 times n plus 2. And so when you work that out, you're going to get n squared plus 4n plus 4. Right? That's the nth figure. N squared plus 4n plus 4 on part G. Of course, that's not the only way to do this, right? That's not the only way to do this. Let me just show you, just to give you a different perspective. Like another thing that you could do is you could group it like this, where I'm counting that as one thing, and then I'm counting this as one thing, and then I'm counting this as a separate thing. So in this case, it would be 5 plus 3 plus 1. And then for figure 2, I might group it like this, right? Where this first column is still its own thing, but then instead of doing just one column in green, I do like 2 columns like this, right? So that I've got this kind of rectangle pattern. And then for the red, I maybe take these 2, right? So this is another way that you could potentially kind of see the growth. And it goes without saying this isn't the only way, of course, right? But this is another way that you might have thought to kind of do it. Kind of like that. And so that the pattern here would be 5 plus 3 plus 1. Then it would be 1, 2, 3, 4, 5, 6. So it would be 6 plus 2 times 4. So this is 1 times 3. So maybe I could say it like this. So maybe I could say it's 5 plus 1 times 3 plus 1. And then the next one would have been 6 plus 2 times 4 plus 2. And then the next one would have been 1, 2, 3, 4, 5, 6, 7 plus 1, 2, 3, 4, 5 by 3, 5, or to keep the pattern, maybe I'll say 3 by 5, and then plus 3, right? So that's another way that you could see that. And so then you can guess figure 4 is going to be, well, it's going 5, 6, 7, so figure 4 is going to be 8 plus 1, 2, 3, 4 times 3, 4, 5, 6 plus 1, 2, 3, 4, right? So for figure 4, you can extrapolate and say, oh yeah, so it's going to be 8 plus 4. Ooh, I'm going to run into the black part. 4 times 6 plus 4, right? So for figure 4, you can kind of extrapolate that, and then you can come up with the pattern that way. You should end up at the same place with the same answer, okay? So a quadratic growth there. And there are other ways to think about it. Like maybe you did, just to give you one more like suggestion, just sort of off the top of my head. Like maybe you thought to group it this way, right? And this way, and this way. And then you had like these extra bits, right, every time. Yeah, that would be another way to think about it. So anyway, lots of ways to think about this. You could go, column by column, or, whatever. But so that's that one. Looking at part H now. I mean, again, lots of ways to think about this. It's like one of the ways that I see it is I've got like this 2 by 3 with like an extra 3 and an extra 2. On the next one, I've got this 3 by 4 with an extra 4 and an extra 2. On this one, I've got a 1, 2, 3, 4, a 5 by 4 with these extra 5 and these extra 2. Right, so I could split it up that way. I could maybe go column by column and call this like 3 plus 4 plus 2 times 2, right? And then this one I can go 4 plus 5 times 2 plus 2 times 2. And then the next one I can go 5 plus 6 times 3 plus 2 times 2 times 2, right? Anyway, so that's another way I could do it. Another way I could do it is to, again, see what's missing. This might require a little bit of illustration, but again, it's like I'm missing 1 there, and I'm missing 4 there. But if I just fill it in like that, well, then I've just got a 4 by 4, right? And here I've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So here I've got a 5 by 5. And so here I'm pretty sure I'm going to have a 6 by 6, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So maybe this is the one that I'll do. This is a 4 by 4, a 4 by 4, but I was missing some pieces. I was missing a 2 by 2, and I was also missing a 1, right? Here I had a 5 by 5, but I was missing a 3 by 2 and a 1. And here I had a 6 by 6, but I was missing a 4 by 2 and also missing a 1. Okay, so I can pretty much guess now that for figure 4, maybe I'll just stick with the same color, but for figure 4, it seems like I'm going to go up to a 7 by 7. I'm going to be missing 2, 3, 4, 5 by 2. And as always, I'm going to be missing that 1. So going up to figure 10, seems like this number is the figure number plus 3, right? 4 plus 3 is 7, 3 plus 3 is 6, 2 plus 3 is 5, 1 plus 3 is 4. 10 plus 3 is 13. So it seems like I've got for figure 10, I would have a 13 by 13, but it would be missing a little piece. Now what's it missing? It's always missing a something by 2, right? 2 by 2, 3 by 2, 4 by 2, 5 by 2. So it's always missing a something by 2. That something looks like figure number plus 1, right? 1 plus 2 is 2, 1 plus 2 is, or 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, 1 plus 10 is 11. So figure 10, I'd be missing an 11 by 2. And then I'm also always missing a 1. Okay, so jumping now to figure n, right? Figure n. I think what we decided is that we had a figure number plus 3 by a figure number plus 3, but then we were missing a figure number plus 1 by 2, and we were also missing 1 little square. So that's the pattern that I came up with. We can simplify this now. We've got n squared plus 3n plus 3n plus 9 minus, let me distribute the 2 first actually. So I'm going to say minus 2n plus 2 minus 1. So let's see, this is n squared plus 6n plus 9 minus 2n minus 2 minus 1. And combine our like terms now. We've got an n squared. 6n minus 2n is 4n. And then 9 minus 2 is 7, minus 1 is 6. N squared plus 4n plus 6. Another quadratic growth pattern there. Okay. All right, so that's all I want to say about those for now.